Hello friends, in today's session we are going to cover some topics regarding enumeration, autoboxing and annotations, that is metadata. Uh, we will cover one example of autoboxing, one more example. Okay, in this example, in the previous session we saw how we use that I object that will be autoboxed and auto unboxed by Java. Okay, so now we will see one example regarding that. We are creating two objects, one of integer I object and second of double D object. I object is initialized to 100, D object is initialized to 98.6, and we are going to add them too. Okay, so whatever the value will be added, like 98.6 plus 100, that will be automatically converted to the double object. So output will be your 198.6. So this example is valid in this case. Both the double object DOB and integer object participated in the addition, that is addition is done, and the result was reboxed and stored in data of object. Okay, because of auto unboxing, you can use integer numeric objects to control a switch statement. Now we will see this example of switch statement. What is the case? Because of auto unboxing, you can use the integer numeric object. So you can pass the integer object to switch case to check whether it is matching with the value or not. Case 1, here we are passing case 1. It is printing 1, and case 2, it is printing 2. So I object is 2, and you can pass it directly without converting into primitive type int. So it will be converted automatically. It will automatically unbox and converted into primitive type, and it will be checked for the value, and output 2 will be displayed. IOB is unboxed and its primitive value integer is obtained, that is int. As the examples in the program show, because of auto boxing and unboxing, using numeric objects in expression is both intuitive and easy, and it is perfectly valid also. Such code would have involved cast and call to methods such as int value. So every time before before Java 5, every time we would have been using, like in this case, it would have been it would require to convert this I object to into primitive type like I object dot int value. So after Java 5, it is not necessary to convert it. It will be automatically unboxed. Auto boxing and unboxing boolean and character values. So Java also supplies wrappers for boolean and character classes. These are boolean and character. Auto boxing applies to these wrappers too. So auto boxing will be applied to all the primitive types and its wrapper classes when it is needed for boxing. So primitive type will be converted to your wrapper class, and when it will be coming to primitive types, wrapper class will be converted to primitive types. For example, consider the program autoboxing of boolean and character we are going to see. Now boolean B is initialized to true. Below B is auto unbox when used in a conditional expression such as if B system out.println B is true. Okay, if B I am passing, this B is true. Okay, and the class is not a small b, so it is a base class, that is wrapper class. So true will be automatically boxed to B as a as converted to object, and this is the object of wrapper class boolean. And when I am passing this B to if statement, this B will be automatically converted to your boolean primitive type, and output is displayed like B is true. Now we will see the example for autoboxing a character. Character X, here is the base class, that is wrapper class for character. So this X will be outboxed and stored into character wrapper class CH, and character CH2 is equal to CH. So here in this case, character will be unboxed and stored into primitive type CH2, that is character. And then we are displaying CH2 with CH2. the output is displayed like this: B is true and CS2 is X. So not any time we had to convert it into primitive type or wrapper class. Okay, so auto boxing and auto unboxing is done automatically by Java compiler. The most important thing to notice about this program is the auto boxing of B inside the if conditional expression. Okay, as you should recall, conditional expression that controls if must evaluate to type boolean. But since auto unboxing is automatically done by Java, so it is done by Java automatically, and also this conditional expression exactly fulfills the rule, that is conditional expression must evaluate to type boolean primitive type. Because of auto unboxing, boolean value contained within B is automatically unboxed when the conditional expression is evaluated. With the advent of auto boxing and unboxing, a boolean object can be used to control an if statement. Because of auto unboxing, boolean object can now be used to control any of Java's loop statements. Okay, so boolean wrapper class can be automatically created to primitive type, and primitive type can be automatically converted to wrapper class. And for because of this, boolean object can be directly passed to any expression, any control statement, and that will be automatically unboxed to primitive type. When a boolean is used as a conditional expression of while, for, do while, it is automatically unboxed into its boolean equivalent. Okay, boolean is very important primitive type. Why? Because conditional expression condition should evaluate to true. Unless and until condition is not true, your code will not be executed. But that is done easily because of Java virtual machines or Java compilers auto unboxing feature. Boolean B, while B. This B you can directly pass over here, and it will be automatically unboxed to boolean primitive type. Now, this will also prevent error. In addition to convenience that it offers, auto boxing and unboxing can also help prevent your errors. For example, unboxing error. Integer I object is equal to 1000. It will be automatically boxed and converted to wrapper class, and object is created I object. Here, I object dot byte value. We are converting this I object to byte value manually, and we are going to store this value into variable I. And here we are trying to print this I, so it will not display the 1000 value because not the expected value 1000 but 224. The reason is that value inside IOB is manually unboxed by the calling byte value, which causes the truncation of the value stored in IOB, which is 1000. Okay, so what we are doing? We are manually converting the value to byte value, and what is expected value? Integer value. Since byte is smaller than int, the value will be automatically truncated and it will be stored in I object. Okay, and we will not get the result as expected. This results in a garbage value 24 being assigned to I. Auto unboxing prevents this type of error because value of IOB will always auto unbox into value compatible with integer. So no truncation will be occurring, and also no garbage value will be stored into the value that is expected to be displayed. In general, because autoboxing always creates the proper object and autoboxing always produces the proper value, there is no way for the process to produce the wrong type of object or value. Because everything is done automatically by Java, so Java will take care of all these things. Like no error should be produced. So you don't have to worry about anything. In the rare instances where you want to type different than produced by automated process, you can still manually box and unbox values. Okay, Java is automatically doing everything. That does not mean that you cannot box and unbox. Whenever you need it, in the very rare cases, you can skip the automated process and you can manually box and unbox values that you want to convert it into. The benefits of autoboxing, unboxing are lost when you are manually doing this. Her new code should employ autoboxing and unboxing. It is the way that modern Java code will be written. So you most of the times you no need to convert it into wrapper class, no need to convert it into primitive type. Everything will be handled by Java. And in the modern codes after Java 5, JDK 1.5, JDK 5, everything will be written using autoboxing and unboxing automatically. Now, there is one warning. Java includes autoboxing and auto-unboxing. Some might be tempted to use objects such as integer or double exclusively or abandoning primitives altogether. We will see one example for that. For example, with autoboxing, unboxing, it is possible to write code like this. Double A, B, C. So here we were expecting double, that is the primitive type small d, A, B and C. Now what we are going to do here, 10.0, 4.0 and trying to calculate the value 10 into 10.0 into 10.0 plus 4.0 into 4.0, and we are trying to calculate the square root. Okay, so hypotenuse is displayed over here. In this case, we would have used like this double small b, that is a primitive double type. But this is the wrong way, because at every type, at every place, Java has to automatically unbox it to a primitive type. Okay, so this will cause the overhead in terms of time, in terms of effort. So instead of writing this, you can directly write a double as a primitive type. Okay, so as and when needed, you can directly use the primitive types, and as and when needed, you can directly use the wrapper classes. But you cannot mix. Some programmers might be tempted to use objects such as integer or double exclusively, abandoning the primitives altogether. Okay, so you should not skip the primitive types. If you need primitive types, you can directly use the primitive types, and if you need the wrapper classes, you can directly use the wrapper classes objects. Objects of type double hold values that are used to calculate hypotenuse of the right angle triangle. This code is technically correct and does in fact work proper. It is very bad use of autoboxing, because at every place Java has to do everything by its own. It is far less efficient than the equivalent code written using the primitive type double. Reason is that each autobox and auto-unbox adds overhead, that is in terms of efforts for Java compiler and in terms of time that Java compiler or our CPU will require. That is not present if the primitive type is used. Okay, so when there is a simple way present, why should we go for the complex one? If a simple way is there, you should go with the simple one. If it is complex one, you can use the auto boxing and unboxing feature. You should restrict your use of type wrappers to only those cases in which object representation is required. Whenever you are requiring object, then only you will use the wrapper classes, otherwise you will use the primitive type. Autoboxing and unboxing was not added to Java as a backdoor way for eliminating the primitive types. So boxing is and unboxing is included in Java. Why? To ease the programmer to program their application. Okay, it is not designed or it is not added by Java as a backdoor way to eliminate the primitive types. Eliminating primitive types means whenever primitive type is required, you can directly use it. You cannot skip it. You cannot eliminate it. Whenever the primitive type is the best choice, you can use the primitive types. And whenever the wrapper class is the best choice, you should, whenever object representation of the primitive type is required, you can use the wrapper class. Now we will see the third topic of this session, that is annotation, metadata, data about data. Beginning with Java 5, a new facility was added to Java that enables you to embed supplemental information into a source file. After Java 5, it is added first of all, and second, it will add the supplementary information to your Java source code file, that is java file. This information, called as annotation, does not change the actions of the program. Annotation leaves the semantics of the program unchanged. It does not change the behavior. It does not change the output of your program. Whatever you are writing, that will be remain intact. So annotation is only providing the supplementary information. This information can be used by various tools using both development and deployment. Okay. This information does not cause any overhead, does not change the output of your program, but this information can be used by various tools during both development and deployment of the Java application. Annotation might be processed by the source code generator. Okay, whenever you are generating a source code, like we were using the thread multi-threading. Okay, and whenever the class was implementing the runnable interface, for example, so while placing our cursor on the class name, there was one option available, add unimplemented method. Okay, after that the code was generated automatically, and that code was like to be auto generated method stuff like that. Okay, so that code is preceded by @ this @ is nothing but the annotation. Okay, so source code generator, whenever is required, like you are generating getters and setters, we are implementing interfaces, or you are implementing the methods provided by interfaces in your particular class, every time, it is the overridden method, it will give you the @ override annotation. So annotation is nothing but the supplementary information that is provided into source code. The term metadata is also used to refer this feature, but the term annotation is the most descriptive and most commonly used. @ precedes the keyword interface. This tells the compiler as annotation an annotation type is being declared. Notice the two members, string and value. All annotation consists solely of method declaration. You don't provide bodies for these methods. Java implements these methods. However, moreover, methods act much like fields, as you will see. Okay, so those annotations are solely of method declaration. First thing, you don't provide bodies. You second thing, and third thing, all the methods act much like a field, as you will see. As you will see means in the preceding, in the upcoming slides. Annotation cannot include extend clause. This is the rule. All annotation types automatically extend the annotation interface. Annotation is the super interface of all annotation. It is declared within java.lang.annotation package. It overrides hash code, equals, and toString methods which are defined by object. So what is the rule? It cannot include the extends clause, but it automatically extend the annotation interface. And this annotation interface is a super interface or main interface of all the annotation, and it is declared within the java.lang.annotation package. It will override three methods: hash code method, equals method, and toString method. And all these methods are declared within the object class. That is the base class of all Java programs. Now, it also specifies annotation type, which returns a class object that represents the invoking annotation. Okay, so annotation type is a method. It will return the class type object of a class that represents the invoking annotation. Once you have declared the annotation, you can use it to annotate a declaration. So first of all, what you have to do, you have to declare the annotation, and then you can use the annotation. Okay, any type of declaration can have annotation associated with it. Okay, for example, classes, method, fields, parameter, and enum constants can be annotated. Even annotation can be also annotated. Okay, this is very important line. What things you can annotate classes, methods, fields, parameters, and enum constants also annotation. Annotation precedes the rest of the declaration. Okay, so annotation @ will be preceding rest of the declaration. That will be the first statement in the whatever declaration you are making. When you apply an annotation, you give values to its members. For example, annotate a method. @my annotation string is equal to annotation example value is equal to 100. So what you are doing, you are giving value to its members. What are the members? String and value. And this is the method. And its annotation is my annotation. Public static void my myth has annotation my annotation. Okay. This annotation is linked with the method my method. Look closely at the syntax. Name of that annotation preceded by @ which is compulsory. It is followed by a parenthesized list of member initialization. Okay, so simple parentheses are added. Whatever members are there, those are initialized within the annotation. To give member a value, that member's name is assigned a value by using the equal to operator. Okay, this is the parameter name string str is equal to annotation example, comma, parameter name value is equal to annotation value, that is 100. Okay, so this is the syntax to write the annotation. First of all, you will write the @ syntax, then whatever annotation name you are giving to your annotation, then the in opening and closing parentheses you are going to give the value. Okay, therefore, and in the example, string annotation example is assigned to the string member of my annotation. No parenthesis follows string in this assignment. When an annotation member is given a value, only its name is used. Okay. So annotation, when you are giving annotation member a value, only you will use its name. And annotation members look like a much look like as a field in this context. Okay. Next is you are specifying the retention policy. So now we will go into detail now into annotation, but before it is necessary to discuss annotation retention policy. Retention policy is nothing but it determines at what point is annotation is discarded. Okay. Java defines 3 such policies which are encapsulated within java.lang.annotation.retention policy enumeration package. Okay. So what is the rule? That rule is written over here. At what point this annotation is going to be discarded, and which is written in java.lang.annotation.retention policy. They are source, class, and runtime. An annotation with a retention policy of source is written only in the source file and is discarded during the compilation. Annotation with a retention policy of class is stored in the .class file during compilation. However, it is not available through the Java virtual machine during runtime. So it is only stored here. It is retained in the source file and discarded during when your compilation is started. Okay. Annotation is the retention policy of class. When you are giving the retention policy as class, it is stored in a .class file during compilation. It is discarded. This is discarded before compilation or during compilation. It is stored in a .class file during compilation, and however it is not available through the actual compilation or actual runtime used through the Java virtual machine. An annotation with the retention policy of runtime is stored in the .class file during compilation and is available through the Java virtual machine during runtime. So these are the 1, 2, and 3 step-by-step policies. First is stored in the source file and discarded during compilation. It is stored, second one class is stored in a .class file, but it is not available at runtime. And runtime is stored in the .class file also at the time of compilation, and also it is available through the Java virtual machine during runtime. Thus, runtime retention offers the greatest annotation persistence. Okay, so annotation will be persisted throughout the program execution where you are specifying the runtime retention policy. The retention policy is specified for the annotation by using one of the Java's built-in annotation. So how I will write it? @retention and retention policy. Retention policy is must be of one of the previously discussed enumeration constant. So whatever policy you are going to generate, it should look like this. Retention and enumeration constant should be there inside the parenthesis. If no retention policy is specified, the by default policy is class policy given. Okay. The following version of my annotation uses @retention to specify the runtime retention policy. Okay. So now we will give it like retention policy dot runtime in the parenthesis, and this it will be available to the Java virtual machine during program execution. @interface my annotation string integer value. Okay. So we are creating the annotation and with retention policy @retention, and which retention policy we are giving? Runtime retention policy. @interface my annotation, and this is the string integer value are given. Now obtaining annotations at runtime by use of reflection. Although annotations are designed mostly for use by other development or deployment tools, if they specify retention policy of runtime, then they can be queried at runtime by any Java program through the use of reflections. Okay. Annotations are designed mostly for use by other development or deployment tools if they specify retention policy of runtime. Okay. If the retention policy is given as runtime, then they can be queried at runtime by any Java program through the use of reflection. So any Java program can use the reflection to acquire the annotation at runtime. Reflection is the feature that enables information about the class to be obtained at runtime. So whatever class you are using, its information can be gathered using reflection. A reflection API is contained in the java.lang.reflect package. There are a number of ways to use reflection, and we won't examine all here. Walk through few examples so that you will understand it better. The first step of using reflection is to obtain a class object that represents a class whose annotations you want to obtain. So you have to first obtain the class object, okay, whose annotation you want to acquire or gather. Class is one of the Java's built-in classes and is defined in java.lang, and it is described in detail later. There are various ways so that we can obtain the class object. One method is very easy method is get class, which is method defined by object. Final class get class. So it will give you the class object of which annotation you want to gather. It returns the class object that represents the invoking object. Okay. So there are some points. Get class and several other reflection related methods make use of the generic features. Okay. Because generics we have not learned generics yet. It is going to be learned into the upcoming sessions. Okay. So these methods are shown and used here in their raw form. As a result, you will see a warning message when you compile the following program. When you will be learning generics in detail, then we will see the actual format or actual syntaxes to how to write these all methods. Which methods? The reflection related methods are explained in detail into the class, that is generics class. Okay. So when we will be coming to that session, you will understand. Here we have used the raw format, and you can have the compile time error. You will see a warning message when you are compiling the following program that we are going to see. Okay. So if you want to go to generics in detail, you can go to that session and learn that how generics are implemented. After you have obtained a class object, you can use its method to obtain information about the various items declared by the class, including its annotation. Okay. First of all, what you will do? You will get the class object using the get class method. After that, you will have you are having multiple methods in the reflection. Using those methods, you can obtain whatever number of annotations that are declared in that particular class object. If you want to obtain the annotation associated with a specific item declared within the class, you must first obtain an object that represents that item. Okay, so if you want to have the specific annotation, not all annotation, not all items annotation, you must first obtain the object that represents that particular item. Class supplies the get method, get field, and get constructor methods which obtain information about a method, field, and constructor. Okay, and this will return the object of that particular type. It will return the object. Get method will give you the object of method. Get field will give you object of field, and get constructor will give you the information about the constructor. To understand how we are doing this, we will see one example. First, obtain a class object that represents the class, and then call the get method on that class object, specifying the name of the method. Okay. Here is the syntax: method, get method, string method name, class, parameter types. So you can see here. Here we are specifying varargs that we have already learned in the previous session. Okay, varargs are nothing but the variable number of arguments. So here you can pass as number of arguments as you need. Method, get method, this will return you a method. Then string method name, class, parameter types. If the name of method is passed, the name of the method is passed in method name. So which methods details you want to learn or want to get, you will pass the method name, and you will pass the parameters over here. If the method has arguments, class objects representing those types must also be specified by the parameter types. Okay. If method is without arguments, no worry. If method has arguments, then class objects representing those types must also be specified by parent types. Parent types is a varargs parameter, as I have already explained. This means that you can specify as many parameter types as needed, including zero number of parameters. Get method returns a method that represents the method. If the method can be found, no such method exception is thrown. From a class, method, field, or constructor object, you can obtain a specific annotation associated with that object by using the get annotation method. Annotation, get annotation, class annotation type. Okay, so class annotation type we will specify in the parenthesis. Get annotation is the method, and annotation will be written. Annotation type is a class object that represents the annotation in which you are interested. So annotation type is a class object that you are getting using the get class method that represents the annotation in which you are interested. The method returns a reference to the annotation. Using this reference, you can obtain the values associated with the annotation member. The method will always return you the reference to the annotation, and this using that particular reference, you can obtain the values associated with the annotation member that are initialized inside the annotation, as we have already seen. The method returns null if annotation is not found, which will be the case if the annotation does not have the runtime retention. Okay, if it annotation is having basic retention type like what we have seen in this source. Okay, basic retention type is source, so it will not have that particular it will not be available through the compilation time, so it will return you null. Here is the program that assembles all of the pieces and also uses reflection to display the annotation associated with the method. Now, annotation type declaration. If you want to get the non-null value, you have to give the retention policy as runtime. @retention, java.lang annotation, and reflect are the classes required to imported. Retention, @retention, retention policy dot runtime, @interface my annotation. So these are the values. Now class meta. My annotation string is equal to annotation example. So this is the my annotation. Okay. So my annotation, string annotation example value is equal to 100. Meta object is equal to new meta. We are creating object of this class. Obtain the annotation for this method and display the value of its member. Get a class object that represents this class. Class C is equal to object.get class. Okay. So this is the object and I want to get the object of this class, object.get class in the try catch. Now get a method object that represents method. C. This object I have got is C dot get method. Which method I want to get? This method, my method. Okay. Public static void my method. Now next get the annotation for this class. M dot get annotation, my annotation dot class. And this will be written as annotation and it will be stored in my annotation object. Finally, display all the values. Annotation dot string, annotation dot value. And then method not found if this method is not present on that in that particular class. And then I will call only my method from the public static void main. So what will be happening into my method? First of all, object of this class will be created. Then after that, I will get the object of the particular class here, object.get class into C. Then C.get method, my method, and it will be stored into M. Then M.get annotation, my annotation dot class. Okay, so my annotation dot class, its annotation I am acquiring and stored into annotation, and annotation dot string, annotation dot values will be displayed. Annotation example and 100. Annotation string is annotation example and annotation value is 100. This program uses reflection technique as described to obtain and display the value of string and value in the my annotation associated with my method in the meta class. There are two things. My annotation is equal to m dot get annotation, my annotation dot class. Expression my annotation dot class. This expression evaluates the class object of type my annotation, the annotation. Okay, so it will evaluate to a class object of type my annotation, and it is nothing but the annotation. This construct is called as class literal or class constant. You can use this type of expression whenever a class object of a known class is needed. Okay. If you are already knowing a particular class and whose object you are requiring, in this case you can use the type of expression my annotation dot class here. For example, this statement could have been used to obtain the class object for meta dot class. This name I am knowing, so I can use this line meta dot class and it will be stored into class C. This approach only works when you know the class name of an object in advance, which might not always be the case. Every time you might not knowing the details of the class. In general, you can obtain a class literal for classes, interfaces, primitive types and arrays. The second point you have to note it down is the ways values associated with string and value are obtained when they are output by the following line. Annotation.string, annotation.value. Notice that they are invoked using the method called syntax. And the same approach is used whenever the value of an annotation member is required. Okay, so this way we have understood the basics of annotation. In the upcoming session, I will try to cover the remaining topics of theory part, that is enumeration, autoboxing, annotation, metadata, theory part 3. So we will meet you in the next session. Thank you so much.